Welcome to the Poly demonstration of protection of transformer by using microcontroller and electromagnetic relay. So in this project we are going to design a protection for this transformer. So though is two transformers, but in our project we are using these two transformers as 1:1 transformer. So nothing but we are providing 230 volts AC inputs. This transformer is actually a 230 volts AC to 12012 output AC. And the another same kind of transformer which is of 3 amps, so which will take 12 volts AC inputs and provide us a 230 volts AC. So for this for this transformer we are providing 12 volts AC from this transformer. So that's why it's calling as 1:1 directly. So that output of the 230 volts given to the load through this current transformer, which is of 750 milliamps power, can be measured by this one, and in series with the electromagnetic relay. The purpose of this electromagnetic relay is whenever the load is increases, then microcontroller will continuously check the load by using this current transformer through this potential divider circuits. When it crosses the limit of around 70 watts of power, then the system will directly off the power supply to the load by using this electromagnetic relay in order to protect the two transformer, this transformer. So considering these two combination of 1:1 transformer. So here the purpose of the potential divider circuitry is, so as we know that CT is a step up transformer, so which is connected in series with the load, so which will has the less number of turns for the primary side, and secondary is the more number of turns, then the voltage will be increases. That is going to be the AC power supply. So the AC is converted into the DC with the help of this IC. The IC name is DB107, which will convert the AC to pulsating DC, and with the help of this smoothing capacitor we will get the pure DC voltage which is above around 5 volts. So for that purpose again we are using the potential divider. So before also potential divider there is 100:10, and after is 10:1, means the voltage is divided by 100:10, and the output exactly at the DC power supply and also DC source and also 10:1 voltage will be divided, and the DC voltage given to the A0 pin of 16F72 microcontroller. So based on these inputs we are going to displaying the status on the LCD, whether it is a normal status or overload status, and if it is overload then we are going to off the electromagnetic relay by switching off the power supply with the help of the microcontroller pin. C3 pin is connected to the electromagnetic relay. So the whole system getting power supply from this adapter, which will take 230 volts AC inputs and 5 volts DC outputs. So when we give the power supply here, so it start executing the inputs and output module. So on this motherboard, this is a PIC motherboard. On this two main components, this one is a reset switch. In our project it is very important to restart the microcontroller. So whenever the overload occurs, the system will isolate the power supply to the load by off the relay, and if the load is coming to the normal, so instead of resuming the power supply to that load, system will ask for the user only, check it properly, and then reset the switch. When you reset that, it checking again and resume the power supply to the load when it is normal load. And next is the crystal oscillator. So the purpose of the crystal oscillator is to provide the clock pulse to the microcontroller. So the main purpose of the clock pulse is to provide the pulse signal. So we have provided the instructions. So one instruction required one pulse, so that controller will execute 20 mega clock instructions per second, as we are providing 20 megahertz per second. So let us see the demonstration. Now it is normal load. So just switch on the motherboard initially, then there will be a welcome message on the LCD screen, and after that status is normal. You can see that. Okay, and just I'm on the main power source to the load section to the transformer. So nowadays status is normal. Right. So by disconnecting that, by connecting the overload, so the system is keep on checking that, continuously monitoring, as there is a light indication over here, so it will show the status of the kit is working. Right now it is overload displayed on the message, and once the load isolated, there is no current, that's why status normal. So by disconnecting that, means by checking the load status when it is normal, then reset the switch again. So the status is normal. So in this manner we can protect the power transformers by checking the currents on the transformer, and when it exceeds the overload, then isolating that power supply to the load to protect the transformer by using the electromagnetic relay with help of microcontroller and current transformer.